Hi, this lesson's topic is Windows API Introduction. Getting along. Your program lives together with other programs on the same computer. How do the programs get along? Just some questions, for example. How can more than one program run on the same processor? Imagine this, you only have one processor, or maybe one processor with a few cores, but only a limited amount of cores. How come you can run so many programs on one computer? How is this possible? Another question. Let's say that two different programs want to read the mouse movement at the same specific moment. Which program will get to actually read the mouse movements? Next question. Let's assume that two different programs want to write to a specific pixel on the screen. How can we decide which program is going to write to that specific pixel? The answer is the operation system. The operation system has full control over the computer. It then shares the resources, the system resources, between the programs. Whenever a program wants to do something which relates to one of the system resources, it has to send requests to the operation system. This is an illustration of how it looks like in a modern operation system. There are a few different programs running at the same time. Each program wants to have access to some of the system resources. For example, memory, processor time, monitor, mouse, or keyboard. And there are many more examples for system resources. Maybe, for example, access to the network, for example, to the internet, or maybe access to the hard disk. The operation system makes sure that no two programs access the same resource at the same time. Whenever a program wants to have access to one of the resources, it has to ask the operation system. As you can see in this picture, no program has direct access to any of the system resources. You might be thinking that it is a bit sad. Maybe you wanted to write a program that has direct access to the monitor, for example, or maybe to the mouse. Let me show you the brighter side of things. There are also a few advantages for this arrangement. Assume for a moment that the user of the computer decides one day to change the monitor to a new monitor. If your program had a direct access to the monitor, you would have to change your program. That is because the monitor has changed, and the new monitor might have a bit of a different interface. However, using this arrangement, whenever the user changes part of the hardware, for example, maybe changes the monitor or maybe the mouse, your programs do not have to change. They can use exactly the same interface against the operation system. With this arrangement, it is the job of the operation system to adapt to changes in the hardware, for example. This idea is called abstraction. The operation system basically abstracts away the details of the hardware of the computer, which is mostly a good thing. Talking to the operation system. As we have seen in the drawing in the last slide, your program has no direct access to the system resources. In the past, by the way, programs did have such direct access. These days, instead, programs can only communicate with the operation system. This kind of communication is done using special functions. Special functions which are given by the operation system, and they are called API functions. API stands for Application Programming Interface. I'll remind you of the previous diagram which we have seen. In this diagram, the API is here. This is the interface between your program and the operation system. Basically, this is all that you have to learn, the API, if you want to be able to program for some operation system. You don't have to know any of the details in this part of the diagram. Windows API. Windows API is a set of functions provided by the Windows operation system. Those functions are used to communicate with the Windows operation system, which means that whenever you write a program, you could use the API functions to communicate with the Windows operation system. You might be wondering where these functions are, or how can you get access to those functions? Well, those functions show up in the form of DLL files. Usually, the API functions follow the std call convention, in which the caller doesn't have to clean the stack itself, where it is the responsibility of the callee to clean the stack. Basically, it means that you don't have to add the instruction add ESP after you finish with the call. Every Windows program relies on few API functions, or else it cannot really do anything. It will not be able to have input or output or get access to any system resource. Even the programs that we wrote, all of them had at least one Windows API function, which was the exit process function, if you remember. DLLs. Previously we mentioned that the Windows API function resides inside DLLs. Let's explain what a DLL is. DLL stands for Dynamic Link Library, and basically a DLL file is just an executable file, or maybe an exe, with the PE format without an entry point. You cannot really run DLL files. You cannot click on a DLL file and expect something to happen. DLL file is just an executable file which only contains functions, but it does not contain an entry point. Other programs can link to DLL files in order to use their functions. For example, you could write a program, an executable file, that uses functions from some other DLL file. In fact, we already did it. For example, the exit process function is a function inside kernel32.dll. DLLs are what we call shared libraries, which means that usually there is only one instance of a DLL loaded to the physical memory, and that is to save space. Let me explain this in a more detailed fashion. DLLs are loaded to the physical memory only once. One DLL could be used by many different programs at the same time. For example, if there are two different programs that use one DLL, maybe kernel32.dll for example, then this DLL is going to be loaded to memory only once. It will appear to each of these programs that kernel32.dll is inside their own address space. However, if we take a look at the physical memory, we are going to find out that kernel32.dll is loaded only once. This is done for efficiency reasons. Instead of loading kernel32.dll many times, it is shared between all of the programs that need it. I want to note a few things about DLLs and APIs. We mentioned that the Windows APIs could be accessed through a few DLLs. However, not every DLL belongs to the operation system. In fact, you could even create DLL files yourself if you wanted to. You can even do it with Fuzzer. As a conclusion, I want to note that not every DLL supplies Windows API. It is true that many DLL use Windows API functions. However, not every DLL supplies Windows API. Let's discuss some common DLLs from which you can call API functions. The first one is kernel32.dll. Inside this file, you could find functions that deal with file systems, memory management, processes, threads, and error handling. We haven't talked about all of those subjects yet, as they are a bit advanced. But basically, you can use kernel32, for example, to read or write files to the disk, or maybe to request memory from the operation system. Those are just examples of things that you can do using kernel32. Next one is user32.dll. This DLL contains mainly Windows API functions that deal with graphical user interface. For example, drawing windows, buttons, and also taking mouse and keyboard input. The next one is GDI32.dll. This DLL supplies API functions that deal with graphics. For example, outputting to monitors, printers, and so on. Of course, there are much more DLL files which supply API functions. Documentation of the API functions. The Windows API functions are well documented, at least most of them. You could find documentation for those functions in the Microsoft Developer Network, which is also known as MSDN. This is the address of the website. If you ever find that you want to know what a specific API function does, or maybe you want to understand how to give arguments to this function, you could just search it in this website, msdn.com. Summary of this lesson. Programs these days do not have direct access to the system resources. Instead, they have to talk to the operation system and maybe request something from the operation system. The communication between the programs and the operation system is done using API function calls. By the way, every operation system has some other kind of API functions calls. In this course, we only deal with the Windows API. Windows API access is done by calling functions inside specific DLL files. The website msdn.com contains a full documentation for the Windows API. See you on the next lesson.